And here we are. Here we are with yet another lecture today regarding the. We will have some problems on probability that we would want to solve, and let's see how many problems we can solve. I mean, we have got an hour of time over here, and these problems would basically be related to probability, and some of the problems would be related to, again, like discrete probability distributions, and some on continuous probability distributions. Yeah. Okay, so once we have, you know, so this is how we are going to, this is how I have planned this particular class, is that I shall, like bring up a problem over here, right? And this problem would be kind of, related to either of the two uh, distributions, either of the discrete or the continuous random variable uh, distributions, random distributions, probability distribution, or densities. So, so it would either be discrete, right, or it would be continuous. And according to the basic requirements of the course that we are learning now, we would only require to understand a few problems on binomial distribution in the discrete, and the Poisson distribution on in the discrete random variable case, and in the continuous random variable case we have to understand certain on the exponential and some problems from the normal distribution. So we will restrict ourselves to these four probability distributions, but I would, of course, at all points of time, want to remind you that these are just a few problems, that a few places where you find, like probability distribution and density. There are at least infinite, and I claim that it's my opinion, that there are at least infinite more probability distribution functions out there. Okay, now without further ado, I would want to, like get into the crux of the matter, and let's start, like solving a few problems and trying to understand how, like how we can apply probability theory in solving a few problems, right? Okay, so the first problem, I have taken a screenshot of the problem from a particular question paper, which is not your question paper, of course, and I am going to share that here, right here in front of you, right? So this is the question. I hope you can all see the question. The question says that out of, maybe I'll just blur off the place where nothing is written, right? Okay, derive. This is not a part of the question. This is not a part of the question. Okay, so the question says out of 800 families with 5 children each, so there are total of 4,000 children. Okay, 800 families, 5 children each. First family has 5 children, second family has 5 children, third family has 5 children, and so on. So 800 families have 5 children each. Total there are 4,000 children. Okay, we are required to find out how many families would be expected, right? We do not know what is the reality, right? So we have to guess, we have to make an educated guess. We have to find out how many are expected to have. First question is 3 boys, second question is 5 girls, third question is either 2 boys or 3 boys,
That is so.
and the fourth question is at most 2 girls, right? So this is our question. We have to find out of these 800 families, how many families are expected to have three boys? How many families will have
Two
five
families.
girls? How many will have two or
One.
three boys? And how many will have at most two girls? Okay, now that we have uh, our like question and the data that is given in the question, we will start writing down. It's an art of writing maths, so we'll try to uh, be the artists here and do justice to the art. Huh? Okay, so this is question one. Now the solution is as follows. We'll write the solution as follows. Here the number of families is 800, right? And see, the thing is that here, what is the variable? What are we counting? At the fundamental level, we are counting the number of boys and the number of girls in the family, in
Sinchana
one
also is there
particular
in our
family.
family.
Sorry, there is someone who wanted to say something. Mm, Okay, so I think some kind of miscommunication happened. Technical. Okay, so we are the variable here. The main variable here is the number of boys and I mean boys or girls in a particular family, right? In a particular family. And once we know the probability of a particular number of boys or girls in a particular family, then we can expect that these many families might have three boys, or maybe those many families might have five girls, or maybe that many families would have like a few more two or three boys, right? And those many families would have uh, maybe two, at most two girls, right? So once we see, the thing is that once we can understand, uh, so basically we need to find out, we need to find out how many families, what is the probability of a particular number of boys and particular number of girls in a particular family. Okay, so what we do is we will write down, we will say that X is the, okay, so we'll say that X is the number. I'll use a blue pen over here. So we'll say that X is the number of boys, right? No offense to any other genders in a family. Okay, because this is the thing that is changing, that I mean the number of boys and number of girls, there are five children total, so number of girls would be 5 minus x, so 5 minus x is equal to number of girls in that family, in the same family, right? So this is a variable. These are the variables. We have no control on them, and these are the things that we have to find out first. Once we find out what is the probability of say three boys in one family, then we can find out how many families like that exist. Hmm? Okay. So this is the first assumption that we are making. Next, we have, so what is the maximum number of children? What is the exact number of children in each family? That is 5, right? So our n is going to be equal to 5. Okay, n is not equal to 800. I will write that in big and red. Okay, n is not equal to 500. Okay, 1 minute. I would want to make a little drama over here in a in a much dramatic manner. N is not equal to 800. Okay, n is not equal to 800, n is equal to 5. We are talking about in one family how many boys are there, in one family how many girls are there, right? So that is the question, that is the fundamental question we are trying to answer. Once we answer that question of how many boys or how many girls are there in just one family, we will be able to we will be able to understand like how many we will be able to understand what would be the number of families with that many boys or that many girls. Okay, so let's get into the problem with a more rigority now, right? So this is a problem with which can be modeled using binomial distribution, right? So we model this problem using binomial binomial distribution. Okay, so I would want you to like go back a few moments in your life and try to understand what are the different like kind of uh, variables or maybe how do I put it? So what are the different parameters that we require in a binomial distribution? So let us try to recall that. In binomial distribution, we want an n, we want a p, right? So here n is equal to 5, right? Number of children in a family. N is 5, number of children in the family. Next we have P. What is P? P is the probability of success. Probability of success. What is the probability of success here? Let's say we are counting number of boys here, right? So the probability of boys is called P. Probability of boys, of a boy in among the children, among the children, right? So the probability that a kid is a boy is basically the value of p, right? Okay, now okay. Hmm. Okay, so the value of now in the question, can you see that the last part of the question says by as so the last part of the question says as follows: by assuming equal probabilities for boys and girls, right? This is what the last part of the question says: assuming equal probabilities for boys and girls, right? We're assuming equal probabilities for boys and girls. What does that mean? It means that if p is the probability of boy, right, then q will be the probability of a girl. Then by the question p equals q, right? But p plus q, what is p plus q? P plus q is 1 because the sum of all probabilities is 1. So since p plus q is equal to 1, so like in place of q we can write p, or in place of p we can write q. So this will be 2p equals 1 or 2q equals 1, and that would give us p equals half. I mean, if p is half, q is also half, right? So p is half and q is half. Okay, so we have got the value of n, we have got the value of p. Now we will try to solve the problem, right? So basically the probability of X number of boys in a family of 5 children with equal probability for boys and girls is given as follows. How does it look like? It looks like all P of number of boys, the probability of number of boys equals to X is equal to N is equal to N C X P power X Q power N minus X, right? So in our case, what happens is as follows. In our case, the value of N and P are available to us, right? What is the value of N? N is 5. So it will be 5cx, then half to the power x, then half to the power n minus x, right? Now, my bad, it's not n minus x, it is 5 minus x, right? So in the value of n is 5, I can realize that. We must realize that we know the value of n. So 5c, oops, the 5 looks like 6. 5cx, and then half to the power, the powers can be added, right? So x plus 5 minus x, and then the x and x get cancelled. So basically it would be 5cx multiplied by half to the power 5. So essentially, we have reached our, we have simplified that the probability of X boys in a family is 5cx multiply half to the power 20 of half to the power 5, right? Well, you can, some of us might be comfortable in simplifying this, and 5cx 1 half to the power 5 would be 1 by 2 to the power 5, which would give us 1 by 32 multiplied by 5cx, right? So this is the probability that there are x boys in a family. Now the value of x can, the value of x, what are the possible values of x here? So the values of x can value the values, I'll just write a small note over here. Note that values of x vary vary from 0 through 5. So 0 through 5 means 0, 1, 2, 3, 4, 5. So the value of x can be 6. So there are 6 different possibilities. One possibility is no boy, 0 boys. Another possibility is there is 1 boy. Another possibility is that there are 3 boys. Another possibility is that there are 2 boys. Another possibility is that there are 4 boys. Another possibility is that there are 5 boys. Okay, so there are 6 possibilities, and all of these possibilities have one probability value attached with that. And what is the probability value? It is 1 by 32, 5cx, right? Okay, and how did we arrive to that? We arrived by using the uh, binomial distribution function. You can see that there are 5 children each, so n is equal to 5. We get it from there, and the value of p is by assuming that there are equal probability for boys and girls, right? So in a very easy story format, we have understood this process, right? It's not possible in the offline class, by the way. Okay, anywho, so we have got till here. Now let's try to find out the answers for each of the questions. Okay, but before going there, right, Before we proceed there, I must, we must go through the following ones. Okay, so we have found out the probability of X boys in a family. The question is asking number of families with X boys, right? So the question is asking how many families are there with X number of boys, or maybe some number of girls and boys and some combination. So basically, like we have to find out the number of families. Now, in the back of your mind, I'm very sure you have this idea. The idea is as follows. Idea is probability probability is same as fraction. Oops, is same as fraction, right? So if I say if there is a half probability of of a particular event happening, that would mean that half of the times that event will happen, right? So the probability is a fraction. Now, in order to get the number from the probability, we should multiply probability with the total, right? So, number of families, right? Number of families, number, number, number uh, of families, of families with X, with X boys is equal to probability of X boys, probability of X boys multiplied by total number. I'll scroll it a little bit. Yeah. Okay. Now I think it is visible. So probability number of families with X boys is probability of X boys, which is a fraction, right? So the fraction multiplied by total number of families. Okay, now try to understand this. How can we write this definition? We can write this definition because the probability is a fraction. We are having a fraction of we are having the ratio, fraction or ratio, fraction or ratio. We're having a fraction or a ratio of the entire population of the families, the number of families which are having X number of boys. So once we multiply this probability with the total number, we will get the number of families. Okay. Now, once we are here, we are totally good to go. But before that, we have some values. Let's change this, English to math. Probability of X boys, as we have seen, is 5CX. I mean, we'll not do anything with this as of now. Okay, so I think there is a 1 by 32 in the beginning. 1 by 32 multiplied by 5 multiplied by 5CX multiplied by the total number of families, well, is 800. Now we can, do some cancellation here and there, and I think it is 32 multiplied by 25 is 800. So we'll be having 25 times 5CX. Okay, 32 times 25 is 800. Is it so? 25 multiplied 4 is 100, and 4 multiplied 8 is 32. So yes, yes, yes. 32 multiplied 25 is 800. Yeah, great. See, again, the calculations are not that difficult as well. And probability, that is a big thing. Okay, so let's look at the question now and try to find out how many families would be expected. Again, this is not the exact number of families. Okay, so there is a very important terminology that I have missed out here. I must not miss out that, neither should you. I am putting that in a red box over here. The the word is expected. Expected. What is the expected number of families with X boys? Expected. We are not writing the exact number of families. It's not possible because the survey is done only to usually when we do a survey, we do a small sample size. We pick up, let's say there are 1 lakh families, we'll pick up 1,000 families out of there. Even if we can take out 1,000 families, that is like really good thing. uh, from 1,000 families or 500 families, we'll find out in how many children are there in each family, right? And that may not be a good representation of the entire sample, entire population, right? Okay, so anywho, let's not go deep into that. Let's try to solve the first problem now. What is the expected number of families? How many families would be expected to have 3 boys, right? So we are trying to solve the first problem here. 3 boys. Okay, so x is equal to 3, right? X equals 3 over here. So expected number of families with 3 boys is equal to 25 multiplied by okay, multiplied by 5c3, right? So the value of x is 3 over here. Okay, so this is same as saying 25 multiplied by, now 5c3, right? How to find out the value of 5c3? Again, since this is since we are in a tutorial now, we can very easily revisit this particular formula. So NCX, right? So if we write NCX, NCX would be n factorial divided by x factorial multiplied by n minus x factorial. Okay, so this is how we are interested in going ahead with the problem. So we have got NCX. N can be any integer value, positive. Remember, all of these n and x should be positive numbers only, positive integers only, natural numbers. They can be 0, but they can never be negative. None of them should be negative, and n cannot be 0 even. N being 0 does not really make sense. I mean, if n is 0, then well, that's a different math altogether. Let's not go there. And the value of x can be at most n. The value of x cannot go above n. So x equals 0, x equal to 2, x equal to 3, so on, so on, so on, so on. X equal n. So there are n plus 1 possible values of x here. Okay, so we have got 25 multiplied by 5c3. So 5c3, the value of 5c3 would be 5 factorial divided by 3 factorial multiplied by 2 factorial. So that is 25 multiplied by 5 factorial is 5 multiplied 4 multiplied 3 factorial divided by 3 factorial multiplied by 2 factorial. So I played a little trick, on the top over here. So 5 factorial I have written as 5 multiplied 4 multiplied 3 factorial. Okay, that's completely legal by the way. And the 3 factorial will cancel them out, right? And once we cancel the 3 factorial and 3 factorial, 2 factorial is equal to 2, we know that. So 2 factorial and 4, if we cancel, then we will get 2 over there. Thank you. Okay. Okay. Okay, so this will get a 2 over there. So 2 multiplied 5 is 10, multiplied by 25, we get 250, right? So therefore, the expected number of families with 3 boys is 250. That is the answer. Okay, now let's move on to the next sub question over here. Right, sub part of the question. It says 5 girls, right? The question is 5 girls. Now, see, remember, we already have the formula. We have made this formula right now. We have made the formula for the expected number of families with X boys, right? Okay, so the next question asks us what is the expected number of family with no with 5 girls, right? 5 girls. So 5 girls, 5 girls. Okay, but our formula deals with only boys, right? So we can, from here we can, we can write the following statement. Okay, we can write the following statement that a family with 5 girls has 0 boys. So basically, if we want to find out the expected number of families with 5 girls, it is equivalent to finding out the expected number of families with 0, okay, with 0 boys. Okay, now let's try to find out that, right? So expected number of families with 0 boys. What is the formula? We have a formula 25 multiplied by 5cx, right? Okay.
ತಾಯಿ ಯಾವ್ದು ನಮ್ಮ ಮನ್ಸು ನಮ್ಗೆ ಒಳ್ಳೇದ್ ಮಾಡಿದ್ರೆ ದೇವರು ಅಷ್ಟೇ
Just a minute.
ಏನಂತೀರ ತಾಯಿಗೆ
Just a minute. Very sorry for the little disturbance. It's an open call and anyone can join. So yeah, I think I have made the necessary changes. Okay, cool. So expected number of families with 0 boys would be as follows, right? So the expected number of families with 5 girls is equal to see, this is equal to expected number of families with 0 boys. So there is no problem over here, right? So we'll be using x equal to 0 anyway. So this is 25 multiplied by 5c0. X is equal to 0. Now, these tutorial classes are the places where we can actually, like have a little mind exercise, right? So I should take the liberty right now to, to explain you that, well, yeah, to explain you that, maybe to inform you that any number C0 and any number C the same number. Okay, it's just a reminder of your high school math. So any number C0 and C any number C1, right? So C the same number, right? So any number C0 and any number C the same number, like 5C0, 5C5, 10C0, 10C10, 256C0 and 256C256, right? So all of these will be equal to 1. Okay, so this is a very important relation, very handy relation that always comes to help, right? So you can of course, use the previous formula here that we have written down here, right? So n factorial by x factorial into n minus x factorial, you can do that. But in this case, if you find something like this, you can directly write 1 over there, right? Okay, so once we have this, we can write this as 25 multiplied 1, and that is 25, correct? So in the previous case, it was 250, and here we can, we can hence write that therefore, therefore the expected, the expected, oops, the D is not expected number of families with 5 girls, is 25, and that, my friends, is the answer. Okay, great. Now let's move on to the third part of the question, and there is a fourth part of the question also. It's pretty lengthy question. Okay, so the second part is done. Now the third part says that there are either 2 or 3 boys, either 2 or 3 boys, right? So again, see, the number of boys can either be 2 or be 3, right? Okay, so this brings us to a very interesting case over here. Okay, the case here, case number 3 is as follows. So x is either equal to 2. No, let me write down in the language of the question. In quotes, either x equals 2 or x equals 3. Hmm? Either x equals 2 or x equals 3. This is the entire scenario that we have in our hand, right? Now here, this is a disjunction, right? So see, it's an either or scenario, so one of them is definitely true. Okay, now in order to find out this, we usually use the principles of inclusion, exclusion, and stuff like that. And and here the probability, right? The probability. Okay, so before I say that, right? In this case, there is an observation that I would want you guys to make. What is the observation? The observation the observation is as follows. The observation is as follows. Well, if there is a family which has got let's say like two boys, can that family have 3 boys at the same time? No, right? So the observation is as follows. Again, I'll just write it down, right? So it will become more clear at that time. If a family has 2 boys, it can't have 3 boys, right? At the same time, these are two observations which I am writing down. There we have got two observations over here. The first observation is if a family has 2 boys, it can't have 3 boys. And the other observation is as follows. If a family has 3 boys, it can't have 2 boys, right? So this means that the situation, the condition or the event of a family having 2 boys and the event that a family has 3 boys are independent of each other, right? So of course there is a huge amount of math involved in proving that these two events are independent. However, these simple observations are giving you enough evidence, right? So from here, I'll just write down what it means, right? In a very simple English set of words. So the event x equals 2, right? So it's an event, right? It's a probabilistic event. X equals 2, and since it's a probabilistic event, I'm writing it in parentheses, right? So event x equals 2 and x x equals 3, right? So these are two events are independent, right? And since they are independent, since they are independent, we can write the following. We can write the following. The probability of x, the probability of x equals 2 or x equals 3 is equal to probability of x equals 2 plus probability of x equals 3. See, again, this concept can be understood by looking at this Venn diagram over here, right? Look at this Venn diagram. I'm drawing the Venn diagram in a different way, right? You can see that on the top, right? On the top, there is this red circle, right? This red circle is one event, and on the bottom, you can see that there is this green uh, set, right? So this green set is another event, right? This in the event, these are all elements from the event space, right? So A and B are independent of each other. So the number of elements in A union B is basically the number of elements of A plus the number of elements of B, because there is no intersection between them. They are independent from each other. So in this case, in the third question, where we have to find out the number of families which have either 2 or 3 boys, what we need to do is we need to find out the number of families with 2 boys, and we have to find out the number of families with 3 boys, and we have to add them. So now things are pretty simple for you, right? So number of families, again, these are not the exact number of families, so we must write expected number of expected number of families with 2 boys is equal to 25 multiplied by 5c2, right? See, what was our formula? This was our formula, right? Expected number of families with x boys is 25 multiplied by 5cx. So here it is 25 multiplied by 5c2. So let's quickly calculate the value here. So 25 multiplied by 5c2 is 5 factorial divided by 2 factorial multiplied by 5 minus 2 factorial, right? So I'm not jumping any step here whatsoever. You should not jump in your exam as well. So 5 factorial, in a smart way, we can write that as 5 multiply 4 multiply 3 factorial. 2 factorial, in place of 2 factorial, well, it is 2 multiply 1. So you can just write 2 multiplied by 5 minus 2 is 3. So 3 factorial here. And you see very nicely, you can cancel this 3 factorial, right? That's why I said that it's a smart way. Okay, and also you can cancel 2 and 4. You'll get a 2 on the top, right, in place of the 4. So 2 multiplied 5 is 10, multiplied 25 is 250. Therefore, the expected number of families with 2 boys is 250. And we, as we had planned, we would also find out the expected number of families with 3 boys. And it turns out that both of these are equal. Okay, so we'll get to that. We'll find that out, don't worry. So expected number of families with 3 boys, right? So this is 25 multiplied by 5c3, right? 5c3. Why is it 5c3? Because look at this formula once again. 25 in the bottom of your screen, right? 25 multiplied by 5cx. That is the formula. We have derived this formula ourselves. We have not memorized it anywhere, right? So it is completely doable by everyone. Okay, so this is 25 multiply 5c3. Well, you know what? We could, go on from here, blah, 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 do the calculation and all, but let's be a little smart. So The smartness stems from this particular relation. It says that NCX is equal to NC n minus x. Okay, so this is again from high school combinatorics, right? It says that if there are, let's say, like 5 children in a family, and we are finding out what is the different number of ways in which there can be two boys, right, in the among the 5 children. So that is same as the number of ways in which there can be 3 girls or maybe 3 boys, right? So see, basically here the probability of boys and girls is the same, so it doesn't make much difference. But this relation, is mathematically correct. In this problem, we have got exactly the kind of interpretation that we need. So this is true for, again, all values of n and x. The condition is that the x should be at most n, right? So x should be less than equal to n. That is the condition. I've written the condition here. So now try to plug in the value n equals 5 and the value x equals 3. You will find out that the 5c3 is basically 5c 5 minus 3. That is 25 multiplied by 5c2. And that's exactly 250, as you had found out a little while back. So thank me for like making life easier for you. The same calculation is not being repeated by you anymore. Cool. So now the expected number of families with either 2 or 3 boys is same as expected number of families with exactly 2 boys plus expected number of families with exactly 3 boys. So that is 250 plus 250, which is equal to 500, right? So this is how we have unfolded this part of the problem. So we have got one more problem left. The fourth problem is left. But before that, I need to check whether things are all fine out here. So can I get a thumbs up from people who have understood it? Okay, okay. I can see Santosh, Tejoswini, Ujjwala, Sagar. Okay, good. Okay, so now let's move on to the last part of the problem. See, again, uh, any problem on binomial, you are going to do it. So the last one is at most 2 girls, right? At most 2 girls. Again, see, the language is very important here. At most 2 girls. Let's write that down. Let's see how we can unfold this problem. At most 2 girls. So at most 2 girls means that there can be 0 girls, right? So let's try to interpret this. Right, there can be 0 girls, there can be 1 girl, and there can be 2 girls. The case 3 girls, 4 girls, 5 girls are not going to be accepted over here. So if there are 0 girls, that is equivalent to 5 boys, because the total number of children in a family is 5. And if there is just 1 girl, that is corresponding to 5 minus 1, right? So because 5 is the total, so that is 5 minus 1, that is 4 boys, and 2 girls is again equivalent to 3 boys, right? So we have got the question reframed here as follows. So the expected number of families with at most 2 girls is equal to yeah, is equal to, again, see here, that here the cases are all or cases, right? So a family can have three boys, which means two girls, or four boys, which is again one girl, or five boys or zero girls, right? So this in this case, again, all these three events are independent of each other, right? So since these are all independent of each other, we can find out their probabilities separately and just add them up, right? So that will solve our problem. So just for the sake of your memory, I am going to draw this Venn diagram. We have been learning Venn diagram since the first module. So you're pretty comfortable with the concept of the Venn diagram, right? So this is, let's say, the event of two zero girls, right? Zero girls. The event of one girl is another, yet another set, right? So see, in these sets are not intersecting with each other, they're all disjoint sets. So since these are disjoint sets, the events are independent. Disjoint sets, independent events. Okay. Okay, so this is the set for two girls. Okay, two girls, two girls. So all of these cases are independent of each other. Therefore, therefore, the expected number of families with at most two girls is equal to expected. And I'm going to write a lot in the next 1 minute, so please bear with me. Expected number of families with with three boys plus expected number of families with four boys plus expected number of families with five boys. Okay, now we have the formula from which we had derived. What is that here, right? The expected number of families with x boys is 25 times 5cx. Now let's see how can we find out our answer over here. So here in the first case, x is equal to 3, right? In this case, I'll put a small speech bubble, x equals 3. In the second case, another speech bubble, x equals 4. In the third case, another speech bubble. Here, the value of x is equal to 5. So basically, we have got 25 multiplied by 5c3 plus 25 multiplied by 5c4 plus 25 multiplied by 5c5. Okay. Now, see, when we have big calculations to do, in mathematics we try to be a little lazy. Uh, so 25 multiplied 5c3 has already been found out in the previous problem, right? Where we use 5c3 is equal to 5c3 minus 2, 5 minus 3, and that is 25 multiplied 5c2, that is 250. So we're just going to write down 250 there. Okay, come on, right? That's not cheating. That's no way cheating actually. Okay, plus now you see that, well, you know what? I'm just going to leave a little space over here because there is another combinatoric trick that I would want to teach you. Huh? Okay, so next we have got 25 multiplied by 5c4. Now again 5c4, 5 factorial, 4 factorial, big factorials you have to write. But there, what if I told you a little secret? What if I told you a little secret here? Interested? Okay, wait for it. Look inside the cloud here. N, if we have n and we have nc n minus 1. So you see, there is just one difference between the number on the top left and bottom right, right? So ncx, right? So the value of x is n minus 1, the difference is just 1, or it is NC1. Okay, so in both of these cases, so in the previously we had seen NCN and NC0, right? So here it is NCN minus 1 and NC1. So in both of these cases, remember, even if you cannot remember, it's fine. I mean, what is there? You can calculate it. But if you remember this, it will be, like math will be more pleasurable doing, right? So this is equal to N, that 25 multiplied by 5 plus 25 multiplied by 5C5, that is 1. NCN is 1. Look at this cloud over here. Where did it go? Here, you see, NCN is 1. So 5C5 is 1, right? So 5C5 is 1 over there. So we are exactly where we should be, right? So we have got the first one to be 250, the second one is 125, right? So 250 plus 125 plus 25 multiplied by 1 is 25. So that should give us how much? 125 plus 25 is 150, right? 25 plus 25 is 50, correct? So that is 150, 150 plus 250. 150, there are two 50s which make it 100, and we have got 100 and we have got 200, so it's 400. See, no calculator required. So therefore, expected number of families with at most 2 girls is 400. Okay, and that completes the question, right? So we have solved this particular question. I mean, of course, in the exam you can, like compress all of these and in a beautiful way you can present it. But this is how we solve the problem, right? So we have got 800 families. 800 n is not 800 here. You now realize it, correct? N is not 800 with 5 families each. So the question is, we have to find out how many families are expected to have. uh, the variable is the number of boys and number of girls, right? So in a particular family, that is the variable. So according to the variable, we decide what should be the x, what should be the n, and which distribution to use. And we have used a binomial distribution here because, see, n is 5, right? There are 5 children in total. That is a pretty small number. It's a manageable finite number. And see, there are two possibilities. It can be a boy, or it cannot, it is not a boy. Either it is a boy or it is not a boy, right? Or if equivalently it is a girl or it is not a girl, correct? So since there are two possibilities, it is a binomial distribution, right? So of course, uh, the possibilities are half for each of them, since in the question it is given that we assume equal probabilities, right? So since the probabilities are equal and these are the only two possibilities, so the probability of success and the probability of failure, p and q respectively, are equal to half. And once we have identified that, we use the binomial uh, distribution function, right? See, since this is a discrete distribution, we'll say that it's a probability distribution function. If it is a continuous distribution, we'll say it is a probability density function. Again, we should also remember that in a probability density function, the value of px does not denote the probability, right? So there we have, will in a continuous random variable, for a continuous random variable, we'll be having a range of values like a to b, and the probability is defined between a and b rather than at a particular point. But since this is a discrete case, the probability is defined at discrete points, at points x equal to 0, x equal to 1, 2, 3. Here the x values are from 0, 1, 2, 3, 4, 5, because there are maximum of 5 children. We have defined the probability of x boys, right, as 1 by 32. In the bottom right corner of the screen, you can see that, right? 1 by 32 multiply 5cx, right? Bottom right corner is there. Now we had to find out the number of families. So we said that okay, uh, probability is basically a fraction or a ratio, right? So probability is basically a fraction or a ratio, not a ration. Probability is basically a fraction or a ratio. So the expected number of families should be the probability or the ratio, the fraction or the ratio multiplied by the total number of families. So 800 is not n, we said that, right? And there we found out the formula. And for each of the given subparts of the question, we identified what should be the value of x, and we solved the problem. Okay, so I am going to stop the screen here.